This is part one for your experiment. So the concept involved or related in this experiment are rotational motions, conservation of energy, and the moment of inertia and angular velocity, which is kinematic rotational motions. So basically, we're gonna be able to utilize, four different concepts in one prompt. So as you can see that I have the notes on your right hand side, so I can always refer back to the notes that you have. So basically, when we are dealing with energy concept, we always says that energy initially is equal to energy at the final. And so now we're gonna have to figure out what types of energy are involved in this source of problem solving. So when you skip down over here, you have the solid sphere and cylinders. So these two have different formulas because they're not the same thing. So of course, when you look this way, they will look the same because they are involved in rotational. So what you have to do is you have to write down radius. I'm just gonna put radius, which is different. They may not have the same radius, they may not have the same mass. So an object starts at rest on the incline at position h. This is the height with respect to the ground. You're gonna have to figure out what the angle is. As well. So from your experiment, what you did to figure out the angle was you figure out the length here, okay? So it will be tan, okay, inverse tan of the height divided by the length. That give you the angle. That's what you did for your labs. So basically, this video is supposed to be useful for the lab and the concept itself, okay? So you've just figured out how to determine the angle right here. So you are tasked to figure out what the final velocity is. So step one. I'm just gonna say write out formula. EI equal to EF. And step two. So let's go ahead and write it down. EI equal to EF. So we're gonna have to determine what types of energy are involved at position 1, position 2. So I'm just gonna say this is 1 and equal to this is 2. That's position with our reference. This one right here, an object itself has a height, so we're gonna write down as mgh. It only has potential energy because it starts at rest. This one, the object start rolling down, so you will have the translational 1/2 mv squared because that's the translational motion. And you also have, this is inertia and angular velocity square. That is rotational. So I'm just gonna go ahead and draw this one. I'm just gonna say this is rotational. So step 2, we're gonna have to say we adding rotational motion, which is I. So I'm just gonna say kinetic rotational is equal to 1/2 inertia angular velocity square. That's the formula for rotational. So now step 3. So I'm just gonna say substitute, omega with that one, so replace it. So 1/2 mg square 1/2. My I is and step 4. Substitute initial. So this one, it says it depends. It depends on the object. So for this one, I'm just gonna go ahead and skip to step 4. And then this omega right here, I'm gonna replace with velocity divided by radius square. It will get a little bit more complicated in just a minute because we have to do a lot of canceling stuff. So I'm just gonna, so mgh is equal to 1/2 mass times velocity square plus 1/4 of that one, because when you multiply 1/2 is equal to 1/4. And then I'm just gonna go ahead and canceling the radius square. So I will have m velocity square. At this point, I have 1/2 mgh is equal to, I combine these two, so it will be 1/2 plus 1/4 mv square. So now I'm start canceling things out. On your left hand side, I have g times h, which is the height. And this one I have 3/4 velocity square. So now I'm just gonna say solve for velocity. So I'm gonna do that is velocity. And in order for you to figure out what the, to get rid of this one, I square root that, square root that, and that's to give me velocity square, velocity by itself. And that's the formula for my that's the formula that can be used to figure out the final velocity of the cylinders. So this one, I'm just gonna say it is solid sphere. You will replace the same process, so I'm just gonna say EI equal to EF, and I'm gonna all the way skip to MGH is equal to 1/2 mv square plus 1/2 I is equal to 2/5 mr square. So it will be 2/5 mr square. And then my angular velocity is radius square. So now I'm start canceling things out. It's mgh plus, you cancel the 2 and you cancel the radius, so it will be 1/5 m v square. Same thing, I have 1/2 plus 1/2 plus 1/5 mv square. Start canceling the masses out. So what I have left is when I add these two fractions, I get 7/10 gh is equal to velocity square. So to get velocity square by itself, I do 10 times gh divided by 7. To get rid of the square root, I do that. So my velocity of sphere is equal to square root 10 gh divided by 7. This is the formula that you need to be able to derive if you are asked to figure out